In previous video, we introduced those terms. Now let's use the following examples to like practice and make sure that we understand the terms correctly. So the first one is this the same as these? Okay, are these two the same thing? Well, if you notice that here for the left side, you see curly braces, that means this is a set. A set just contain, it's just think about this as a container. It has something in it. And then on the right hand side is just a single number. So they are not the same thing. This is just a single number, but this is a set. And this set has only one element, which is the element is 0. Okay, so they are not the same. So nope. Okay. By the way, this is a set. And by the way, this set is a set with one element, which is the 0, the number 0. And the right hand side is just a number, a single number, which is 0, right? Single number 0. So they are not the same thing. One is set, the other one is just one single number. Now let's take a look at another one here. So this is a set notation. You see the curly braces right there. And the question is, how many elements are in this set? Now we're going to count. The first element that I see is a single number, which is 1. It's just a natural number 1. And the second element in this set I see is a set. It's a set, and this set is quite small. It just contains one single element in this set. So I see two different things in this set. So therefore, this set, there are two elements, and they are 1 and 1, right? So those are the two elements in this set. Okay, two elements. Now true or false, okay? True or false. And these true or false problems are checking your understanding on these two symbols. This is when we use this means elements of, and this means the subset of. So we introduce those in here. This means elements of, this means subset of. Okay, the first question is 1 an element of this set? Yes, I do see it. It's right there, right? So therefore, 1 is an element of this set. So therefore, it's pretty trivial. Now the second thing is this guy an element of this set? Well, then I'm trying to look for what's inside this set. Do I see this set? I actually do not see this set. So therefore, this is not an element of that, right? So this is not, nope, because this set is not in here in this set. If this set were like this, 1 and then 1, 2, 3, then I would say yes, I do see these elements inside this set. Then I would answer yes. In this case, I would say yes in that case, but not in this case. Now let's take a look at another one. So 1 is a subset of this set. Well, I would call this as kind of abusing mathematical notation. Because when I see this symbol, that has to be, we refer to subsets. This is not even a set, right? Not even a set. So therefore, not appropriate this case. So basically I will say this is not correct. No, this is not even a set. So it's not appropriate to say it's a subset of some other set. So it's just not true. Now let's take a look at this one. So is this a subset of that? Now if you look at the definition, always look at the definition. Definitions are important stuff. So what does it take for us to conclude one set is subset of the other? Then you have to look at all the elements of this set A and then make sure any elements you see from set A must be in set B. Then if that's true, then yes. So here we see that there's only one element in set A, and do we see it in the set B? Yes, of course. So therefore, yes. Now let's take a look at this one. So this is a set. Is this set a subset of this guy? Then we're going to look at, do we see these elements in this set? Do we see it? Nope, I do not see any one single number 1 in this set. I do see a set that contains this set which has only one single element 1. However, when you use this notation, we are looking at when we determine whether this subset is when we determine whether this set is a subset of this one, we scan through all the elements in this set to see if we can see that there, right? Now I do not see 1 in here. Okay, so therefore, no. Of course, if you say, is this a subset? Would this be true? Yes, because I see these elements right there, okay? Then I would say yes in this case. Now let's take a look at the last one. So now this guy is this one element of this set. So the reason I say I did not use subsets because I see this notation. This notation means elements of, right? So therefore I'm treating this as one element. Do I see these elements in this set? Yes, I see it. It's right there. So therefore I would say yes. Okay. All right. So that's the first example. Several examples. Let's move on to talk about the Cartesian, the cross products. Okay, cross product, Cartesian product. Now, A has 2 elements in the set X and Y. B has 3 elements, which is 1, 2, 3, and C contains A and B. Let's find A cross C. Well, maybe quickly review what the Cartesian product, or sometimes we just call it cross product here, what that is. So the cross product, the Cartesian product, A cross B, it contains all the ordered pair. What are the ordered pairs? The first element will have to come from the first set. The second elements come from the second set. That's it, right? So now let's take a look at. So in other words, A cross C, basically what is A? A is this set X, Y. What is C? C is this set A and B, has 2 elements. So now we are going to try to find them. What's in this result? They have to be order pairs, okay? Order pairs. And the first elements must be coming from A. So I have X. So this is the first possibility, right? Second element is coming from C. So X, comma A. Now, of course, the second element could be B, right? Because B is also coming from set C. And now, this is another possibility, Y comma A, and Y comma B. And that's all the possible combinations. So you can see that this must be coming from, must be an element of A cross C, because this is from A, this is from C. This is from A, this is from C, and so on and so forth. Okay, so there were 4 elements, and I would not be surprised that there were 4, because 2 times 2, which is 4. There were 4 total. And hopefully you can figure out what A cross A is. So this will be simply just all the order pairs XX, XY, YX, and then YY. Now let's take a look at the next one. Let's make it a little more complicated. A cross B cross C. And this one will be, A will be X and Y. B will be 1, 2, 3. And C will be A, B. So I'm going to list them all here. And then now I'm going to list a few elements. Well, actually, how many elements that are in this A cross B cross C? This is 2, this is 3, this is 2. If you multiply them together, which is going to be 12. There are a total of a list of 12 elements that are in this A cross B cross C. So let's list a few. Well, they will be 3 tuple, like order, not order pairs, but 3 elements. The first one must come from A. The second one come from B. The third one come from C. So this is my first element in this set. And sometimes it might be it will be a good idea to list all the results systematically. Like here, I keep the first 2 the same, and I change the last one to cover all the possibilities, and then I change the say the second one, x2, and then A, and then x2 B, and then change the second one again, x3A, x3B, and then the next set will be, now we have 6, right? 6, and then similarly, the first one can be y1A, y1B, y2A, y2B, and then y3A, y3B. Actually, we list them all out. Instead of listing a few, we list them all out now. All right, now let's take a look at that one, okay? So here I again encourage you to pause a moment and check your understanding to see if you are mastering this concept. So here, this actually is a set. So here how about we first find this set? This set will be, so I'm gonna write this as, so what is A cross B? We did not do that. We find A cross C, A cross A. So now let's find A cross B, okay? So it will be A cross B, by the way, it will be a set, okay? It will be a set. I should use curly braces. And here should be all the ordered pairs. And the first element, first component coming from A, the second one coming from set B. So like x1, x2, x3, and then y1, y2, and then y3. So that's all the elements from A cross B. So first of all, this is that. Now certainly we want to find cross C, right? C is a set that has 2 elements like AB. Now therefore we have the results here we are looking at should be a collection of the pairs. Okay, so I'm gonna first write here this component should be coming from the first set here, and the second component should be coming from the second set here, right? So therefore here I'm gonna begin, I would like to begin to list by, so the first one is x, comma 1, parentheses, and here this can be A. So I hope that you see a typical elements here. Let me write it bigger. So it's gonna be x, comma 1, and then A. So this is my first elements in this result. So it's a kind of like nested order pairs, right? Now the second one can be, okay, I'm gonna keep my x1 the same, and then this will be b, okay, and then x2, and then a, and then x2 comma b, okay, and so on and so forth. So I hope that you see the pattern, and then how many elements are there. There will be a total of, there were 6 here and there were 2 here, so it will be 12. Now lastly, what is R by R? This actually, R means real number, real times real cross real. So that if according to the definition, it should contain all the order pairs where such that A is in R, B is in R. A and B, they're both real numbers. For instance, by the way, because we have infinitely many real numbers, so therefore this set will be an infinite set. So here, for instance, just one example, like here, 1 and 1 comma 2, right? And say there another example like 3 comma negative 3 comma 1, and this is where we usually the x and y plane. So when you have 1 and 1 comma 2, so 1 and 2, which is this point, so that's what this point represents. Negative 3 and 1, 1, 2, 3, negative 3 and 1, which is that point. So this is another point. So basically this is the R by R is just the xy plane or Cartesian plane. All right, these are the few examples that help you understand the concept. They're worth reviewing. I hope that you are kind of can at a very proficient level to do all these problems.